Hi, this is just a short video describing some of the vocabulary used in matrices. First, we're going to talk about row echelon form, then reduced row echelon form. Now, in order for a matrix to be in row echelon form, all the zero rows must be at the bottom. The first non-zero entry is a 1, and then for two successive rows, the leading one in the higher row is farther to the left than the leading one in the lower row. All four of these matrices are in row echelon form. You'll notice the very first matrix here. We have all ones, and the leading one in the higher row is further to the left than the one in the row below it. There are no all zero rows, so that doesn't matter. And everything to the left of these ones are zeros. Then for the next matrix, we do have an all zero row, and we have our ones here. Our leading ones do follow rule number 3. The last two matrices happen to be in something called reduced row echelon form, and in reduced row echelon form, you look at your ones, and above and below your ones, if you look above and below this one of course, are all zeros. Above and below this one are both zeros, and above this one is all zeros. So the very first matrix is in reduced row echelon form, and the second matrix in this row also conforms to that, because below we have all zeros, and then I do have a zero row, and it is at the bottom, and then my next one above and below are all zeros. So this would be in reduced row echelon form. The last topic on this vocabulary video is going to be that of an augmented matrix, and that's just taking a system of equations, placing it into a matrix. As you can see, I just took their coefficients, and the values that this matrix equals are in the very last column. This is actually my X column, my Y column, and my Z column. Not that it really matters whether it's X, Y, or Z, but everything in that column must be an X. All of these values must be an X coefficient, all of these values must be a Y, and all of these values must be a Z, and this must be what the equation itself equals. Now, there is such a term as a coefficient matrix, and that's exactly what it sounds like. It would just be this matrix right here, which lists the coefficients, and that would be the coefficient matrix right here.